Questions 21 to 25 of the 1999 Grade 10 Cayley Math Contest. A number is formed using the digits 1 through 9. Any digit can be used more than once, but adjacent digits cannot be the same. Once a pair of adjacent digits has occurred, that pair in that order cannot be used again. How many digits are in the largest such number? All right, so they've given us two rules. And those two rules are that adjacent digits cannot be the same and previously used pair cannot be used again. So let's start trying to figure out the largest such number. And as I create this number, I will try my best to explain what exactly is going on. So we can only use the digits from 1 to 9. So if we want the largest such number, we begin with the largest digit, which is 9. Now we get to the second digit. Can I use another 9 because I want this digit to be as large as possible? And the answer is no, because adjacent digits cannot be the same. So I can't put 9, 9. But can I put 9, 8? Sure, I can do that. Now let's get to the third digit. Again, I want this digit to be as large as possible. So can I put a 9 here? I can. Now we get to the fourth digit. Can I put a 9? Well, no, because rule number 1 will not be met. Can I put an 8? No, because that's where rule number 2 kicks in. You can't put a previously used pair again. So I put 9, 8 already. I can't put another 9, 8. So I can only put a 9, 7. Next digit, can I put a 9? Does it violate any of our rules? No, I can put a 9. But how about the next one? Can I put a 9? No. Can I put an 8? No, because that will become 9, 8. Can I put a 7? No, because that 9, 7 pair has already been used. So I'm only left with 6. And as you keep going, you'll notice it'll become like this. 9, 4, 9, 3, 9, 2, and then 9, 1. Okay? Now, I'm going to continue this number. Remember, it's going to be a very long number. But what choice do I have at this point? I can only use 8 because the 9s are exhausted. After the 8, what can I put? Can I put a 9? And the answer is no, because look, 8, 9 has already been used. Can I put an 8? No, because that would violate rule number 1. Can I put a 7? And the answer is yes. And then the next digit, can I put a 9? No, because 7, 9's already been taken. Can I put an 8? Yes, I can. Can I now put a 9? No, because 8, 9's already been taken. Can I put a 8? No, because that would violate rule number 1. Can I put a 7? No, because 8, 7's already been done. So I can only put a 6. And similarly, if you just keep following these two rules, you'll see that this becomes 8, 5, 8, 4, 8, 3, 8, 2, 8, 1, like that. And I'll just explain it for the 7s, and then hopefully by that point you will have understood this. So now the 8s are exhausted. So now, can I put a 7? Sure. What's my next number? Can I put a 9? No, because 7, 9's already been taken. Can I put an 8? No, because 7, 8 is already taken. Can I put a 7? No, because that violates rule number 1. Can I put a 6? Yes. And similarly, this becomes 7, 4, 7, 3, like that. All right? And you just keep on going, following the same rules, same pattern, and you'll get a big long number. This is one number, by the way. I just can't draw it all here because there's no space. It's one continuous string of digits. 5, 4, 5, 3, 5, 2, 5, 1, 4, 3. We're getting to the end. So that's good. 3, 2, 3, 1, and then 2, 1. Now, I've exhausted the 9s, 8, 7, 6, 5, 4, 3, 2, and now can I put any more digits? Can I put a 0? There's no zeros. Can I put a 9? And let's see if I put a 9, is there any violation? Does it violate rule number 1? Nope. Does it violate rule number 2? Is there a 1 9 anywhere else? And I don't believe so. And at this point, that's it. We've hit a full stop. There's nothing else we can add. Because if you try to add any other digit, you'll notice that that pair has already been used. So this is totally the end of it. So now what they're asking is how many digits are in this big long number? All right. Well, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 here. I'll write it in red. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 here. 10 here. 8 with the 5s. 6 with the 4s. 4 with the 3s. And finally we had 1, 2, 3. Like that. So add up all these and you will get 73. All right. So the answer is B for number 21. A main gas line runs from P to Q. From some point T on PQ, so let's say it's here, a supply line runs to a house at point M and to a house at point N. What is the minimum total length of pipe required for the two supply lines? All right. So basically, what is the minimum total length of this red line segment that I wrote? We're going to have to draw this a bit bigger. All right, let's start labeling this now. So this is 55 right here. This is 105. This is 130. This is point M. This is P, Q, N, and this is our point T. And the question is telling us that there is a point T on PQ, which we wrote, and a supply line runs to house at M. So there's a supply line that goes from like that. And then we have another second supply line from T to a house on point N. Like that. Okay? And they want us to find the minimum total length of pipe required for these two supply lines. So how do we make this red line segment the minimum? All right, so the first thing I want to do is draw a perpendicular from N all the way up to the top like that. And therefore that will be at a right angle. And then if this is 55 here, this is going to be 55 right there. And therefore this is 105 minus 55, which is 50. All right? And at this point, I can calculate this right here, this perpendicular that I drew with Pythagoras. It'll be 50 squared, I'll call it h, plus h squared is equal to 130 squared. All right, using this triangle right here, MN to this point. So solving, we get h squared is equal to 16900 minus 2500. And that is 14400 is h squared, and therefore h is equal to 120. Okay? So now what do we do here? Well, remember, we want this red line segment from M to T and from T to N to be the minimum possible. So what we can do is we can use a little bit of a trick here and put a reflection of N here and then connect T to that reflection like this. And if we do that, then the shortest distance between M and N reflection will be our answer. It'll be the shortest or minimum length of the pipe required. Does that make sense? That's basically the quickest way of doing this. So how do we now figure out the distance from N to N reflection? Well, we will need to use Pythagoras again, but on a larger triangle. A triangle like this, like that. So the triangle that I'm referring to, from M all the way to there, and then from the top all the way to the bottom, and then M to N reflection is what we're trying to figure out. So M through T to N reflection is that line that we need to figure out. And using Pythagoras, that is going to be the distance from here to here squared, which is h. That's going to be squared. Plus the distance from here to here squared. Well, the distance from M to P was 105, and the distance from here to here is just the distance from here to here, which is 55, because this is just reflecting from here. So it's 55 on this side, it's 55 on that side. So this is also 55 because it's directly parallel and higher up. So the distance from M all the way across to here would be 105 plus 55 squared, like that. So I'll bring this over here. So we've got this mn squared, this line, is equal to h squared, 120 squared, plus 105 plus 55 is 160 squared, like that. So this is 14400 plus 25600. And when you add them, it becomes 40,000. And therefore, mn reflection squared is 40,000, and therefore mn is equal to the square root of that, which is 200. So that's the shortest distance from M, right here, all the way till N reflection, and therefore that represents the shortest distance from N to T and from T to N. So it was 200, so therefore the answer is 22 is A. How many integers can be expressed as a sum of 3 distinct numbers chosen from the set 4, 7, 10, 13, all the way up to 43? All right, so first, let me write out the set just to give a clearer understanding. So this is our set. It's 4, and then 4 plus 3, which gives you 7, and then plus 3, which gives you 10, and plus 3, and so on. So as you can see, every number increases by 3. And they want you to find the sum of 3 distinct numbers. So for example, if I chose 13, 22, and 43, 13 plus 22 plus 43, this sum is equal to 78. So what they want us to find is how many integers can be expressed as a sum of 3 distinct numbers chosen from the set. So how many different possibilities are there for a possible sum? This is just one that I gave you. How many of these can we get? All right. So how do we approach this? So let's look at each term and see what kind of format it's in. The first one is 4. The next one looks like 4 plus 3. The next one looks like 4 plus 6. The next one is 4 plus 9, and so on, right? That's sort of the nature. So that means that the nth term in this set is equal to 4 plus n minus 1 times 3. Right, you can test this out. When n is 1, it'll be 4. When n is 2, it'll be 4 plus 3, which is right there. When n is 2, we already did. When n is 3, it'll be 4 plus 6. So this is our formula for the nth term. So we simplify this. This becomes 4 plus 3n minus 3, which is 1 plus 3n. This is another way of writing it. Now, the nth term is equal to 1 plus 3n. And how many terms are there? Well, if you look, there are 15 terms. All right? So therefore, that means that n is anywhere between 15 and 1. Okay? So now, we want to create the sum, according to the question, of 3 elements in the set. If you look back at the question, we want the sum of 3 distinct numbers chosen from the set. So we want the sum as follows. The nth term, so we want 1 plus 3n, that represents one term, but it's a different distinct term, so I'll just label it NA. And then we want another term, 1 plus 3n, we'll label it B, just to denote that it's different. And then finally we want a third term, and it's going to be of the form 1 plus 3n, we'll denote it NC. Just to show that these n's are different, and an n is between 1 and 15. Right? So now the sum, if we add this up, is 3 plus 3na plus 3nb plus 3nc. We can factor out a 3. We get 1 plus na plus nb plus nc. All right? And n is anywhere between 1 and 15. So what I like to do is use extreme case scenarios now. We want to create as many sums as possible that are different. So let's start off with the smallest possible sum that I could ever create. And since n is between 1 and 15, the smallest is when NA is equal to 1, NB is equal to 2, and when NC is equal to 3. Right? So essentially we're choosing the first term of the set, the second term of the set, and the third term of the set. So that would give you a value of 3 plus 1 plus 2 plus 1 plus 1 plus 2 plus 3, which this results in 21. All right, so that's the smallest possible sum. Now let's go to the next possible sum. We choose 1, 2, and 4, let's say. The first term, the second term, and the fourth term. So that would give you 3 times 1 plus 1 plus 2 plus 4. And that looks like 6 plus 2, 8. 8 times 2, 24. All right? And let's use one more here. Let's keep going. If we added the first term, the second term, and say the fifth term, what would we get? We would get 3 times 1 plus 1 plus 2 plus 5, which is 7 plus 2 is 9. 9 times 3 is 27. So you see all the sums are going up by 3. Now, let's go to the largest possible sum instead of doing this over and over again. Well, n is between 1 and 15, right? So the largest possible sum is when you have 15, the 15th term, the 14th term, and the 13th term. So that would result in a sum of 3 times 1 plus 13 plus 14 plus 15, which is 3 times 43, which is equal to 129. So this is the largest possible sum. So all of our sums are going to be of this form: 21, 24, 27, going up by 3, all the way up to 29. So I'll write them out. I won't write them all out, but I'll write them in a little bit of an order. So we have 21, our sums. 21 is a possible sum, 24, 27, 30. You see what's happening? 33, all the way till 129. So we have to figure out how many of these are listed. Well, if you count these, you will get to a number of 37. So there are 37 possible sums. All right? So that would be choice B for number 23. The sum of all values of x that satisfy this equation is, so this equation is basically x squared minus 5x plus 5 to the power of x squared plus 4x minus 60 equals 1. All right, so how do you approach this? So we got x squared minus 5x plus 5, and then the exponent is x squared plus 4x minus 60, and this is equal to 1. So is there anything that we can do to simplify this? Well, if this is equal to, say, a, and this is equal to b, this will look like this. A to the b is equal to 1. And how do you get a result of 1 when you have a as the base and b as the exponent? Well, there's a few possibilities. Possibility 1 is if a is 1. If a is 1, doesn't matter what b is, this will be true. It'll be 1 to the power of b, and that's always going to be equal to 1. So that's our first possible scenario. Another possible scenario is if b is equal to 0. That would make it a to the power of 0, and anything to the power of 0 is equal to 1. Okay? And then our third possibility, and this is the one most students miss, is if a is equal to negative 1, and, this is important, b is even. So, for example, it would be negative 1 to, let's say, if b, let's say, is 2, negative 1 squared, and that is, of course, equal to 1. So we have 3 scenarios that we have to individually calculate. So let's start with the first one, which is this one right here. A is equal to 1. So this is a right here. So we have to set that equal to 1. X squared minus 5x plus 5 is equal to 1. All right, here we go. So we got x squared minus 5x plus 4 is equal to 0. Can we factor this? I think so. X, 4, 1, minus, minus. There you go. So x is equal to 4 and x is equal to 1. All right? So these are the values of x for which we make a equal to 1. So we've got 2 solutions so far. Now our next scenario is when b equals 0. All right, what is b? Well, this is b right here. So we want to set x squared plus 4x minus 60 to 0. All right, let's do that down here. X squared plus 4x minus 60 is equal to 0. So can we factor this? I think maybe. X and x, 10 and 6 and plus minus. So that means x is equal to negative 10 and 6. So we've got two more solutions. Now we got our final possibility, which is a is negative 1 and b is even. All right, what's a? X squared minus 5x plus 5. So x squared minus 5x plus 5 is equal to negative 1. And b is even. X squared plus 4x minus 60 is even. All right, let's figure this one out. We're running out of space here. X squared minus 5x plus 5 is equal to negative 1. We can do it here. That way I don't have to keep scrolling down. We've got enough space. All right, so we got x squared minus 5x plus 5 is equal to negative 1. X squared minus 5x plus 6 is equal to 0. So this factors to x, 3, 2, and minus like that. So x is equal to 2 or 3. All right, but we have to also meet this condition, and both have to be true. So let's start with x equals 2 and see if this is even or not. So if x is 2, we have 2 squared plus 4 times 2 minus 60. And this is 4 plus 8 minus 60, which is 12 minus 60, which is minus 48. And that is indeed an even number. It doesn't matter that it's negative. Even is good enough. So x equals 2 is another solution. And then finally, let's see x equals 3, what it does. If x equals 3, does this become even or not? So we will get x squared, which is 9, plus 4 times 3, which is 12, minus 60. So this is 19 minus 60. 9 plus 12 minus 60 minus 39, which is an odd number. So x equals 3 is not a solution. All right, so let's go back and circle all our solutions. We have these two, 4 and 1. We had these two, and we had one final one, x equals 2. So what are they asking for in the question? The sum of all values of x that satisfy that. So we have to add up these x's. All right. So we have 4, 1, 2, minus 10, and 6. And that will equal 3. So the sum is 3, and therefore the answer is 24 is B. If A equals 3P, B equals 3Q, C equals 3R, and D equals 3S, and P, Q, R, and S are positive integers, determine the smallest value of P plus Q plus R plus S such that A squared plus B to the cubed plus C fifth is equal to D to the 7th. All right, oh boy. Okay, so let's write this out. A squared plus B to the power 3 plus C to the power 5 is equal to D to the power 7. All right, let's start substituting. So A is 3 to the power of P, all squared. B is 3 to the power of Q, all cubed. C is 3 to the power of R to the power of 5. And D is 3 to the power of S to the power of 7. So this becomes 3 2P plus 3 3Q plus 3 5R and 3 7S. All right. Now where do we go from here? Well, I think that we can factor out this 3 to the 2P, and if we do, we get a 1. This becomes 3 to the Q minus 2P. And this becomes 3, 5r minus 2p. And this is just 3 to the power of 7s. All right, so let's move this up a bit. Now, this times this is equal to 3 to some power. Therefore, this must be a multiple or factor of 3. And that's the only way this equation could hold true. So we have to think, how is this possible? How can we possibly get that to be a factor of 3? Well, if this was equal to 1 and this is equal to 1, then this would become 1 plus 1 plus 1, which is 3. And that's a factor of 3. So that would mean that 3 to the 3q minus 2p is equal to 1. And 5r minus 2p as the exponent, base of 3, is equal to 1. All right? Now this is only possible if these are zeros, correct? 3 to the power of 0 is 1. So 3q minus 2p is 0. And same thing here, 5r minus 2p is 0. So that means that 3q is equal to 2p and 5r is equal to 2p. Okay? So far so good? All right. Now, we have to now work with these two equations. 2p equals 3q. So 2p looks like it's a multiple of 3. And then 2p also equals 5r. So it looks like 2p is a multiple of 5. So if it's a multiple of 3 and it's a multiple of 5, it must be a multiple of 15, perhaps. But that would mean that 2p equals 15. It could be, but that's not possible because p is an integer. And if you do it like that, it becomes 7.5, right? Remember, going back, p, q, r, s are all positive integers. So 2p is not equal to 15. 2p must therefore be a multiple of 30. That's the only way we can make it an integer. So if 2p, for example, was 30, p would equal 15. All right? We have to make these integers, and that's why we have to ensure that what we call it is accurate. So if 2p is a multiple of 30, we can write it in that form, 30n. All right? So now let's go back to our equation right here, this one, and substitute what we have. We have 3, 2p, but we're calling that 30n. And then we have 1 plus, remember, 3q equals 2p, so that means this became 1. So that's 1. 5r we set to be 2p, and this became 1. So this is 1. And we've got this lone 3 to the power of 7s. All right? Like this. So now we have 3 to the 30n times 3 equals 3 to the 7s. Okay? So this becomes 3 to the 30n plus 1, because this is 3 to the power of 1, is 3 to the power of 7s. And therefore, the exponents must be the same since the bases are the same. So 30n plus 1 equals 7s. Now we just have to solve this using inspection. So let's make a table n and s. And both both of these have to be integers for this to work. So let's try n equals 1. When n equals 1, s is 4.4. So that doesn't work. When n is 2, s becomes 8.7. So that doesn't work. When n is 3, s becomes 13. So there you go. We've got a solution. Now that we know what s is, we can solve for all of these. All right? So let's solve for p, q, r, and s. So the first one is 2p is equal to 30n. Remember, we set that up here. So if 2p is equal to 30n and n is 3, 2p is equal to 30 times 3. So that means 90 is equal to 2p, and therefore p is equal to 45. So we've got our first one. Well, we have s is equal to 13, so we have actually 2 so far. Now we just have to find q and r. Well, we set up here that 3q is equal to 2p. So 3q is equal to 2p. So 3q is equal to 90, and therefore q is equal to 30. And the last one we get is r, which is right here. 5r is equal to 2p. So 5r is equal to 2p. 5r is equal to 90, and therefore r is equal to 18. All right, so what is the question asking us? What is the value of p plus q plus r plus s, the smallest value? All right, p plus q plus r plus s. So p plus q plus r plus s, 45 plus 30 plus 18 plus 13. And I purposely chose the smallest value of s. I didn't keep going here, 4, 5, 6, because that's what they want. They want the smallest value of this. So this totals 106. So let's go back and see if 106 is one of the answer choices. And it is. It's choice C. So the answer to number 25 is C.